Hi, my name's Matthew Adams. I'm a solution architect at Elastic, and today I wanted to record a short video to show how Elasticsearch can be used from Python Jupyter Notebook. And this is because Elasticsearch is a great data backend and probably underused for data science, and anybody working in Python Notebook can start to use the Elasticsearch client for data processing. So please be gentle with my Python. This is something very quick knocked together to show the high-level principles. But I've created this Python notebook to do some fairly simple analysis of some London Tube status data that I happen to have. I've got a file with 10,000 data points of tube lines and what the status is. So I'm going to write I've got some Python here that I've written to look through that data and do some sort of simple analysis. So I've got to load the file in, it's in JSON, which is fairly useful, and then I'm iterating through that data as it sits on file. I'm collating all the status points and names, so we'll have the name of the tube line and the status of that tube line. So I end up with a load of lists. If I come down here, I'm going to select a particular tube line by name, so I'm going to look at the district line. And then what we can do is use NumPy to get a unique set, so essentially doing an aggregation. So get a unique set of statuses and give me a count of number of data points for each status. So then I'm going to assign those to labels and counts, and then I'm going to plot that data into a pie chart. So let me just run through that. So let me do the imports. And then I'm going to actually process the data, and then I'm going to create the counts, and then I'm going to create a pie chart. So you can see from our sort of 10,000 points on disk, we actually get 909 points to do with the district line, and we can give a fairly simple pie chart. Obviously, when most people are using Python Notebook, they're doing things that are far more complicated than this. But you're always going to be limited by processing data from file, which is not fun, and also the amount of data you can use for analysis is going to be fairly limited. So what I wanted to do is to show how we could convert this over to use the power of Elasticsearch. So I have a cluster here that's actually sitting in Elastic Cloud that is ingesting tube data, and I've built some dashboards inside Elasticsearch. So the dashboards are particularly good. You can do a lot of analysis inside Elasticsearch, but often people will want to do analysis outside of Elastic directly. So this is where we can use the client to pull data into Jupyter Notebook. So if I look at the Discovery tab, we can see what some of these documents look like. But really what we're focused on is the name and the status. So the name of the tube line and the status that it's giving back. So what we can do is I've come over to the Elasticsearch DSL and I've installed this using pip, and then we're going to do something very similar that we've just shown before, but we're going to use Elasticsearch as the data source. So if I come to this second notebook that I've put together, again I'm going to import the plotting libraries, and what I'm then going to do is I'm going to import the Elasticsearch library, the search function, and the connection. Now I need to set up the connection, so I'm going to use this cloud cluster. So this is the endpoint for the cloud cluster, and I need to give it the authentication. So in this case I've created a specific read-only user for Python in my cluster. If we come down here, we can now build a search, and the nice thing about Elasticsearch is we can both filter down the data using a search, and then we can apply the aggregation in the Elasticsearch cluster. So this offloads a lot of the actual work from your machine and can pre-process this data fairly heavily and just bring back exactly what you need. So in this case, there's a lot more options that you can do in search, but to match what we've done earlier, I'm doing a query, I'm doing a match, and I'm matching the name. I'm going to match it to district. If we come down here, I'm then going to add an aggregation to that query. So I'm going to call that aggregation status counts. I'm going to do a terms aggregation, So again, similarly, that's going to take all the unique terms and do a count. I need to give it the field. In this case, it's status.keyword because we're doing an aggregation, so the keyword field is important. I'm going to then run that response, and then I'm going to just loop through the response I get, which is pretty small, to then just assign those labels and counts to separate lists so that I can plot them in exactly the same way that I plotted before. So if I come up here, I can run this notebook. So let me run the imports, and then let me run the query, which is also pretty quick, and then let me run the plot. So this has been sort of plotted pretty much the same, but you can see the number of points is vastly larger, and there's practically no limit to how many data points I could actually do this aggregation over, because Elasticsearch scales very heavily. You can put petabytes of data into Elasticsearch and still use it as the back end of your data, and the analysis that you'll have to do in Notebook is going to be more or less the same. So that means that you can bring in whatever data it is that you actually need to do the analysis that you want to do. So this is a very, very quick whistle-stop tour of using Elasticsearch in Jupyter Notebook, and I hope it's been useful. Please do download the client, start using the Elasticsearch client, and start pulling in data for the analysis that you're currently doing in Python. Thank you very much.